Let's take a look at parabolas. If you've learned about quadratic equations, chances are you've probably already seen the term parabola. So let's go ahead and take a look at the definition you may have already learned for parabolas, as they're dealing with quadratic equations. Here, a parabola is the U-shaped graph of a quadratic function. So if we take a quadratic function and we graph it on the coordinate plane, we could get an upward-facing U-shape like this, or we could get a downward-facing U-shape that looks like this. Now, parabolas are not just limited to an upward or a downward-facing U-shape. There's a lot more to parabolas than just that. So let's go ahead and take a look at a couple other definitions of parabolas to help us understand exactly what they are. That will also help us understand how parabolas are not just limited to opening upward or downward. Now, with this definition, it's sort of a visual look. Here, a parabola is the curve formed by the intersection of a plane and a cone when the plane is at the same angle as the side of the cone. Now, let's go ahead and take a look at that visually. So, let's draw a cone. Then, let's say we take a plane and intersect or slice that cone. But we want the plane to intersect at the same angle as the side of the cone. So, when we do that, we'll have a plane intersecting this cone. Something like this. Now, where the two intersect, this is what we get. This U shape right here. This is a parabola. And if we think back to the definition of a conic section is a curve that's formed by the intersection of a plane and a cone or a double cone. So a parabola is just a type of conic section. Neat. Okay, let's go ahead and take a look at another definition. This one is a bit more detailed, and it deals with the graph. So with this definition, a parabola is the set of all points in a plane that are the same distance from a fixed point called the focus and a fixed line called the directrix. Well, what exactly does that mean? Let's take a look. Say we have this parabola here. We already know a little bit about it from what we learned with quadratic equations. This vertical line that cuts our parabola into two mirrored halves is called the axis of symmetry. Now, where the axis of symmetry meets the parabola, this point right here is called the vertex. Now, with this definition, we actually introduced a couple more terms, the focus and the directrix. Let's look at those. This line right here that runs perpendicular to the axis of symmetry is the directrix. Now, following this definition, from the directrix, we can measure up to a point on the parabola. Then, from the parabola, that same point, we measure to a fixed point. That's called the focus. Those two measurements are the same. Any point that we pick on the parabola will have that. So, let's say that this point right here is our focus. So, that means we should be able to pick any point on this parabola. If we pick this point right here, measuring from that point to the focus, and then from that same point to the directrix, these two line segments are the same length. That will happen with any point on the parabola. So, if we pick another point on the parabola, and we measure the distance from that point to the focus, and then from that same point to the directrix, these two line segments have the same length. And we can keep doing this again and again for any point on the parabola. The distance from the point on the parabola to the focus and that same point on the parabola to the directrix will be the exact same. They'll be the same distance. Neat. With these new definitions we introduced, parabolas are no longer limited to just being vertical, opening upward or downward. We can see other types of parabolas now too. You might also see horizontal parabolas. Those open left or right. So we can have a parabola that will open like this to the right, or we can also see a horizontal parabola that opens like this to the left. One important thing to note is that only the vertical parabolas pass the vertical line test. So these parabolas are the only kinds that are functions. These other types of parabolas are parabolas, but they fail the vertical line test, so they are not functions. So now we know a whole lot more about parabolas.